Okay, 5.1, simplifying your trig identities. Anything that is in a yellow box, you need to put on your yellow pages. So the reciprocal and quotient identities are sine equals 1 over cosecant, cosine equals 1 over secant, those are those ones we just did, and tangent is your 1 over your cotangent. And then you have basically the reciprocal of that. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. You also have to remember from when we did our unit circle, tangent is sine over cosine, cotangent is cosine over sine. You're probably going to use these more than anything else, so make sure you draw all those on your yellow pages. Okay, so we have sine squared plus cosine squared equals 1. You can also manipulate these around. So I can move sine squared over here or cosine squared over here. So you're also going to have 1 minus cosine squared, equals sine squared theta. And if I move, and then if I move, instead of moving the cosine squared over, I can move the sine squared over, and I can have 1 minus sine squared theta equals cosine squared theta. Same thing with these ones. I can move my tangent squared over. I can leave my tangent squared there and move the 1 over, or I can move my 1 over and leave the tangent squared there. So this also equals tangent squared theta equals, your secant squared theta minus 1, or your 1 equals secant squared theta minus tangent squared theta. Same thing with this one. I can move these over, and I can also get cotangent squared theta equals cosecant squared theta minus 1, or I get 1 equals cosecant squared theta minus cotangent squared theta. Okay, so next we have the cofunction identities. So my sine, if you remember, we kind of did these earlier on your test. This is pi over 2 is 90 minus theta. This is the complement. So sine is equal to cosine of the complement. So whatever the angle is, if the other angle is 90 minus theta, my sine equals cosine, and vice versa. My cosine of theta equals sine of pi over 2, so sine of the complement. So that basically means, let me try and draw a picture just so you see what I'm saying. So if I have a triangle here, and this is theta, then my complement right here, pi over 2 minus theta, is the sine. So if I have opposite over adjacent, this side's also going to be an A, this side's going to be an O, but really, this is your adjacent over opposite, so it's kind of backwards from what you think it's going to be. So my sine of this triangle, which is your opposite over your hypotenuse, is the same thing as your adjacent over your hypotenuse on the regular one. And then if I look at tangent of theta is equal to cotangent of pi over 2 minus theta, and vice versa. Cotangent is equal to the tangent of pi over 2 minus theta. Those two go together. So you notice sine and cosine go together, tangent and cotangent go together. Then on my secant goes with my cosecant. So the secant of one triangle is the same thing as cosecant on its complement, and cosecant is the same thing as secant. So basically those two go together. Then we have even and odd functions. So think of sine of a negative theta as being in the fourth quadrant. So sine in the fourth quadrant is negative. So you'd have to put negative sine of theta in the first quadrant. So these are even and odd functions. So sine of negative theta is negative sine theta. Same thing with cosecant of negative theta is negative cosecant theta. So sine and cosecant, when they in the first quadrant it's positive, but in the last quadrant it's negative, so you need a negative there. Then cosine in the last quadrant, in the fourth quadrant, is the same as cosine in the first quadrant, so they both will be positive. So cosine of negative theta is the same as cosine of theta. Secant of negative theta is the same thing as secant of theta. Tangent in the last quadrant is negative. So tangent in the last quadrant is negative of whatever the tangent is in the first quadrant. So tangent of negative theta is equal to negative tangent. Cotangent of negative theta is negative cotangent. Okay, so some ideas to simplify. You're going to try to get all your terms into sine and cosine. If you get them into sines and cosines, things will start to cancel out. You can substitute things. 2, try to get rid of fractions. 3, you're going to add or subtract 2 fractions if you have them. You'll probably have to get a common denominator because more than likely your denominators are not the same. Use factoring. Especially, you're probably going to use a squared minus b squared the most. That factors to difference of squares. That will come up a lot. 5, you're going to use substitution of your identities and manipulation of those identities. So back a couple slides on that yellow pages where you have the white boxes where I kind of manipulated and moved things around. You'll have to use those. 6, never divide each side by a trig term. Numbers are okay. So you can divide both sides by a 2, but don't divide by, like, let's say a sine of x, because when you do that, you lose one of the terms. Instead, you're going to move them all to one side and simplify or factor. And then also you're going to use copy dot flip. So copy the first fraction, change division to multiplication, and flip your fraction.